Hello students, today we're going to take a look at solving quadratics using radicals. We're going to look at this for the next couple days. First off, when solving quadratic equations using radicals, we refer to their solutions as the roots or zeros, which also, like I said, kind of refers to the same thing as solutions. So don't be confused by the interchanging of all three of those. All right, the curved line of the graph of a quadratic, which you can kind of see down below here, this is what we call a parabola. And don't worry, you will not have to graph any of those right now. You're just going to look at the traits that happen or look at the graph and see, looking for a couple things based off of it. So you will be given the graph in this unit. Now, these roots or zeros, which are the solutions, represent where the line would cross the x-axis on the graph. So we're going to be looking at these 2 points here in a second. And so this is the x-intercept, where if you recall from going back to linear and lines, to get the x-intercept, we had to plug in y was 0. So right here and right here, to get the x-intercept, that is where y would equal 0. All right, now off of that, let's go ahead and take a look at number 1. So for both of the following, state the roots and zeros based on the graph. So you don't have to solve anything, you don't have to set anything up. You are only looking for these intercepts to find essentially your solutions, which are the roots and zeros. So for this one, we are going to have 2 solutions because the curved graph crosses twice. The first one, and depending on which way you look at it, you've got a positive 3, or over here you've got a negative 3. So that would be it. That's all you have to look at and understand at this point. We'll get into more depth of that at a later time. I do want to point out, for 3 or negative 3, we can also write that same thing as plus or minus 3. So a lot of times you'll see it written this way, but it represents both positive 3 and negative 3 from this side. So going forward, I'll write these as this, but it really represents both. Okay, for number 2, this time we have a parabola that opens down, and we'll get to how and the logistics of why it opens down later on. But for now, we're looking to see where does it cross this x-axis. In this case, it is at positive 1 and negative 1. So like I showed you on the last one, we're going to write plus and minus 1. And that's it. That's all we have to do on those 2. So don't overthink that, hopefully. All right? So there's the first 2. Pause if you need to catch up. All right, let's go ahead and move down here to number 3 on the bottom. Now, when we're solving equations with radicals, we are going to find these roots where if we were to graph this and plug in y in for 0, as we talked about up here, now we don't have to graph it, but we can still find the solutions. So for this one, we're going to need to isolate x squared. So we're going to add 25 to both sides. We want to get x squared by itself, and so we get equal to 25. Now once we do that, we can undo this being squared by taking the square root of both sides, or taking the radical of both sides, as we've been working on the last couple days. So the square root of something squared is going to just be, we're basically going to take half of that exponent, as we hopefully learned in the last couple days. So x to the first, we don't need to write the 1 up there. And then the square root of 25 is 5. So now if you think back, we had 2 answers on these right here. With x squared, we have to account for positive or negative, because with x squared, if you think, if we plug this in, 5 squared minus 25 will equal 0, because you get 25 minus 25. And then if we were to do the same, but with negative 5 squared, minus 25 equal to 0. If we make sure to use parentheses, negative 5 times negative 5 is a positive 25, and that gives me 0 as well. So I'm just explaining the reason why it's plus and minus when we solve this, but you won't have to do this every time. I just want to make sure you understand the reason why we put positive and negative 5 here is because if you were to substitute that back in, you could have either of these would work into this equation. Okay? So there's number 3. Now, on number 4, we want to get the variable by itself, the m squared, so we're going to add 144 to both sides. We get m squared equals 144. To undo something squared, we're going to take the square root of this, and if we do this operation to one side, we have to also do that operation to the other. And so the square root of 144 is 12. And then because of, like we explained here, we have to put positive and negative 12. Because we could have a negative 12 squared here that would end up with an answer, or once you sub it in, you would get 144 minus 144, which is 0. So there are those two. You won't have to show this work every time. Like I said, that's just to help to explain that. So let's go ahead to, that was page 26. Let's go ahead to page 27 here. And so we've got several more examples. Again, we're trying to isolate the variable. So we're just going to solve for n squared. So we divide both sides by 6 now. And we get n squared equals 4. So with n squared equaling 4, now, once we've isolated the variable squared, we take the square root of both sides. So n is going to equal the square root of 4 is 2. So it's plus and minus 2. And that's it. There is number 5. Number 6 looks a little bit intimidating, but we need to solve. So we need to get r squared by itself. So we're going to divide by 9 because it's negative 9 times that. So to undo multiplication, we're going to divide by negative 9. We have r squared equals negative negative a positive 9. And then to undo the squared, we take the square root, and we get r equals plus and minus 3. Because the square root of 9 is 3. So there are those two. Excuse me. For number 7, as we go here, we need to get a squared, even though it's on the other side, we need to get it by itself. So we're going to subtract 37 from both sides. Right? And then we get a negative 9 is equal to a squared. When this happens, well, sorry, now we got a squared. We're going to take the square root of both sides. Now, we cannot get a real solution here whenever to taking the square root of a negative number. So this would be no real solution for what we could do there. So a doesn't actually equal anything. Now, if you think back to the graph, I do want to point out if we had a graph of this, we could solve it. It would open, for a graph to be no real solution, it could be a parabola that opens like this. Because remember, your solutions are where it crosses the x-axis. A graph like this, you would still be able to graph this eventually at some point, which you may see down and below on Desmos, but because it does not cross, it doesn't have any x-intercepts, that's why there's no real solution for that answer. Okay? For number 8, we want to isolate b squared, so we add 21 to both sides. We're going to get 121 is equal to b squared. We're going to undo that by taking the square root, and you can use your calculator. Square root of 121 is 11, and so we have to account for positive or negative. So there you go. There is number 8, 7 and 8 right there. All right, for number 9, we're going to add the 72. We need to get c squared by itself. We get c squared is equal to 72. To undo the square, we are going to take the square root of both sides. So c is equal to, now, 72 is not a perfect square. This is the first one we've had. The last couple days we've been working on simplifying square roots. So if we take 72 and break it up into 36 times 2, we're going to basically look at the prime factorization and then look for pairs of roots or square roots so that we can say that essentially that one's going to cancel out the square root. So 36, I can go to 6 times 6, and we still have the 2. I could keep going into 2s and 3s, but once I have a pair, essentially I have this. So the 6 is going to go out front, as we should have learned the last couple days, and the 2 is a leftover under the square root, so that goes here. Now, the only thing I haven't accounted for is that, remember, when we bring the square root into the question, you have to account for positive or negative. So it is plus or minus 6 radical 2 on that one. So any questions? If you have questions, certainly reach out on Canvas on that. All right, number 10, we're going to get g squared by itself, so we add 54 to both sides. When we do that, we get g squared is equal to 54. To undo the square, we take the square root of both sides, and we're going to have g is equal to, we know it's going to be plus or minus, but once again, 54 is not a perfect square if you test on your calculator. What ends up happening, we come over here, much like I did with 72, I'm going to go 2 times 27, which would lead me to have 2 times 27 is 3 times 9. and then I'm down to 2 times 3, and 9 would be 3 times 3. So I can only take a pair, so these I could take, and this 3 would be separate. So because remember, this is all under the radical. These are left over, so the pair of 3's becomes a 3, and the left under the radical becomes the 6. 2 times 3 is the 6. So I get plus and minus 3 radical 6. All right, so that kind of completes all the work on here. Now the last 4, I'm sorry, and feel free to pause if you need at any point to catch up with that. The last 4 here, these you're going to go to Desmos on your laptop. So hopefully you have these written down, or you have the page, so you can write these down and then test these out. For number 1, you plug it in, you're going to type it into Desmos. You should see that we get a positive or negative 15 for that one. Okay, for the second one, number 12, it's actually going to open down. It's going to be an upside down parabola, so it opens down this one, but you still get plus and minus 3 for that one. This graph, number 13, you're going to find that it actually does not have it. So both of these, you're looking for the x-intercepts. So right here, this one, the x-intercept will actually not cross. So that is similar to what I was mentioning up here with this. So for 13, it is no real solution. You can abbreviate with NRS. And then the last one, which is a little bit interesting, something you're going to see in tomorrow's work, but you can certainly type it into Desmos. For this one, you should get the intercepts are at -2 or at -8. So that is going to wrap up things for today. Make sure to use Desmos to test out those last 4, and reach out if you have any questions. Thank you.